We have often heard and seen in movies how bulletproof glass protects against bullet attack. Many new cars to come also mention bulletproof glass as a feature. From a superficial perspective, we all know what is bulletproof glass, but have you ever tried to know it in detail? Do you know how bulletproof glass is made? How it works? So let's start by knowing. Although everyone calls it bulletproof glass, the more technically correct term is bullet-resistant glass, because it would be difficult to create a piece of glass the thickness needed to make it truly bulletproof, while still maintaining visibility and communication. At first glance, bullet-resistant glass looks identical to an ordinary pane of glass, but that's where the similarities end. An ordinary piece of glass shatters when struck by a single bullet. Bullet-resistant glass is designed to withstand one or several rounds of bullets, depending on the thickness of the glass and the weapon being fired at it. So, what gives bullet-resistant glass the ability to stop bullets? Traditional bulletproof glass is made from alternating layers of 3 to 10 mm thin glass and plastic, where the plastic is simply a thin film of polyvinyl butyryl around 1 to 3 mm thick. Newer, stronger kinds of bulletproof glass use a sandwich of glass and plastic made of acrylic glass, ionoplast polymers such as stentry-glass, ethylene vinyl acetate or polycarbonate, with the thick glass and plastic layers. The laminated glass layers are bonded together with chemicals such as polyurethane or PVB, and the chemical process, which often occurs in a vacuum to eliminate air pockets that could weaken the bonds, strengthens the glass, and makes the layers easy to see through. Then the unit is pressurized and heated to solidify the bonds. This is one tough piece of glass. The unit is cooked at a much higher temperature, up to about 150 degrees Celsius, and pressure up to about 13 to 14 times normal atmospheric pressure in an autoclave, which is a kind of industrial pressure cooker. The main difficulty with the process is ensuring that the plastic and glass layers stick together properly, with no air trap between them, and ensuring the autoclave's heat and pressure doesn't distort the plastic, so it becomes difficult to see through. Have you ever caught a fast-moving baseball? If so, you will be familiar with how to gradually move your hands back to reduce the speed of the ball. The hand's movement reduces the force on your hand, so the catch hurts less. Scientifically, the rate at which momentum of the ball changes is equal to the force the ball puts on your hands. Therefore, changing the ball's momentum gradually decreases the force on your hand. If you try to stop the ball instantly, it will hurt you more. And if you take 2 seconds to stop the ball by moving your hands back, it will hurt you less. The same rule applies in the case of an ordinary and bulletproof glass case. Same as when a bullet strikes bullet-resistant glass. It flattens out as its energy is spread sideways through the layers. The energy is quickly absorbed, and the projectile is slowed enough not to penetrate the pane or do much damage. If it does, although the glass will break inside the layers, the bonded plastic keeps it from shattering forward, protecting those behind it against both flying glass shards. Ordinary glass shatters in radiating fractures from the point of entry of a bullet, and the glass does nothing to slow the momentum of the projectile. In fact, the glass shards resulting from a bullet entry can be as deadly as the bullet itself. So this is everything from our side about bulletproof glass. Hope you've learned something useful today.